Hello students, we are solving a question on rotation from 24th January shift to JEE Mains 2026. The question says a thin rod X of mass capital M and length capital L is pivoted at a height L by 3 as shown in the figure. The rod is allowed to fall from the vertical position and lie horizontally on the table. The angular velocity of this rod when it hits the top of the table is. So in this diagram you can see they have pivoted the rod at a height L by 3. So when it's going to fall, it's going to become horizontal, and we need to find with what angular velocity does it hit the table. So basically we need to find the angular velocity when the rod becomes horizontal, right? So obviously the center of mass is currently at a height L by 6 from the pivot, which is L by 2 minus L by 3. So when the rod falls, the center of mass has fallen by a height of L by 6. That is one thing to keep in mind. Second thing is, we need to find the moment of inertia about this pivot I. The moment of inertia about the pivot I can be calculated using parallel axis theorem, IC plus md square, where IC is the moment of inertia about a parallel axis passing through center of mass, which is into the board, of course, passing through center of mass, and d is the distance between the two parallel axes, means this distance, which is L by 6 itself, right? So applying IC for a rod we know is ml square by 12, md square is m into L by 6 whole square, which is ml square by 12 plus ml square by 36. If you calculate this, this comes out to be ml square by 9. So this is the moment of inertia about the pivot. Now we shall apply conservation of mechanical energy. The decrease in potential energy of the rod should be equal to the increase in its kinetic energy. The decrease in potential energy of the rod is mg L by 6 because the height is reduced by L by 6 of the center of mass, right? This should be equal to half I omega square, which is the kinetic energy gained by the rod. So mg L by 6 is half I is ml square by 9 into omega square. You can now cancel out the small m on both sides. You can cancel out one of the L on both sides. Now obviously here you have 18 in denominator, 6 3s are 18. So if you see the value of omega or angular velocity just before it hits the tabletop comes out to be root 3g by L, which matches with option.